Hello everyone. In today's lecture we will study domes, one of the oldest and most efficient large-span structural systems. A dome is a curved roof structure that can cover large areas without internal columns. Because of its shape, loads are distributed evenly, making the structure strong and stable. Domes are widely used in temples, stadiums, museums, exhibition halls, and public buildings. In this lecture we will learn the basic terminology, different construction techniques, and the advantages and disadvantages of various dome construction methods. A dome is a hemispherical hollow structure that usually forms the roof or ceiling of a building. Domes were first constructed in ancient civilizations such as the Middle East, India, and the Mediterranean region. Their curved shape allows loads to be transferred efficiently to the supports, making them extremely strong and durable. Domes also perform well during earthquakes and strong winds, because the loads are distributed uniformly throughout the structure. To understand dome construction, we should know some important terms. The apex is the highest point of the dome. A cupola is a small dome built on top of a roof. The extrados is the outer curved surface, while the intrados is the inner curved surface. The haunch is the middle portion between the base and the top of the dome. The springing is the point where the dome starts rising from its supports. These terms are commonly used in dome design and construction. Many construction methods are available for building domes. The presentation introduces flattened conduit, tube and hub, beam and hub, panelized timber frame, stress skin, monolithic foam and render, space frame, and brick and former techniques. Each method has its own construction procedure, cost, advantages, and limitations. Engineers select the appropriate technique depending on the size of the dome, available materials, budget, construction speed, and intended use of the building. The flattened conduit technique is one method for creating these large span structures. The flattened conduit method is one of the simplest dome construction techniques. It is easy to build, and the components can be assembled and dismantled without special tools. This makes it suitable for temporary structures and small projects. However, the joints do not finish at the same level, resulting in an uneven surface. Because of this, the dome can usually be covered only with flexible materials rather than rigid panels. The tube and hub construction technique uses specific connectors to join structural members together. In the tube and hub method, steel tubes are connected using specially designed hub joints. This method produces a neat appearance because all the members finish at the same level. It is economical and relatively easy to construct. However, although it works well with flexible covering materials, fixing rigid roofing panels is more difficult. Therefore, the choice of roof covering should be considered during the design stage. The beam and hub method utilizes wooden beams connected by specialized hubs to form the dome's framework. The beam and hub method uses beams connected through specially manufactured hubs. One major advantage is that it does not require specialized tools or advanced construction knowledge. However, the hubs are expensive and not easily available because they must be specially fabricated. Another limitation is poor ventilation when boards are fixed on both sides of the beams, which may cause moisture, dampness, or dry rot in enclosed spaces. A panelized timber frame uses prefabricated sections to create the dome structure. The panelized timber frame method uses factory-made timber panels that are assembled at the construction site. This method is very fast and suitable for permanent dome structures. Since the panels are prefabricated, construction quality is generally good. However, there is limited flexibility for changing the design. Also, fixing materials on both sides of the panels may reduce ventilation and create moisture-related problems inside the structure. The stressed skin technique relies on the outer surface to provide structural integrity to the dome. The stress skin method is considered one of the most economical and efficient dome construction techniques. The materials are simple and can often be obtained locally. However, metal surfaces may collect moisture when temperatures are low, making insulation necessary. In addition, creating openings for doors and windows may weaken the dome if they are not designed carefully. Proper detailing is therefore very important. Finally, the monolithic dome is constructed using a combination of airforms, urethane insulation, reinforcing rebar, and layers of shotcrete over a concrete footing, creating a highly durable and integrated structure. The monolithic dome is constructed by first inflating a PVC airform membrane to the required dome shape. Polyurethane foam is then sprayed onto the inner surface to provide insulation, followed by fixing reinforcing steel bars. Finally, concrete is sprayed over the reinforcement to create a strong structural shell. This method produces a very strong and energy-efficient structure. However, the PVC membrane can be damaged easily, the materials are less environmentally friendly, and additional ventilation systems may be required because the structure is almost airtight. Another construction method for large-span structures is the space frame, which is often seen in public buildings like airports and exhibition halls. A space frame dome is built using steel bars, connected by steel balls with accurately machined fixing points. The members form a three-dimensional framework that efficiently distributes loads. Space frame domes are widely used in airports, exhibition halls, sports arenas, and other large public buildings because they can cover large areas without internal columns. Although construction is relatively simple, the system is expensive and generally unsuitable for small do-it-yourself projects. The brick and former technique is a traditional method for constructing domes. The brick and former is one of the oldest methods used for constructing domes. A temporary wooden former is first built to the required shape, and bricks, stones, or concrete are laid over it. The former supports the materials until the masonry becomes self-supporting. This technique produces very strong and durable dome structures that can last for centuries. It also allows the use of reclaimed building materials. However, constructing the wooden former is expensive and time-consuming. After construction, the former becomes redundant, making this method less economical for very large dome structures. Let us summarize today's lecture. Domes are strong, durable, and efficient large-span structures that have been used for centuries. Different construction techniques, such as flattened conduit, tube and hub, beam and hub, panelized timber frame, stress skin, monolithic foam and render, space frame, and brick and former, offer different advantages depending on project requirements. Civil engineers should select the most suitable method based on strength, cost, construction speed, maintenance, and durability. Thank you for your attention.